So the scale we've looked at previously is using a couple of terms in order to be able to calculate and determine what a full recurrence relation is, and then be able to use that to get consecutive terms beyond what we have. So what I'm going to do in this video is I'm going to set you a couple of questions based on this. I want you to have a go at these, come back and check your answer with the working and the solutions that are available in this video. So here you go. First one, linear recurrence relation un equals a un minus 1 plus b has the first three terms 5, 13, 29. I want you to determine a and b and find the relation. Second one, recurrence relation has un equals a un minus 1 plus b again. Has three terms u1 equals 2, u2 equals 4, u3 is 10. Determine the values of a and b and find the relation. Third one takes it a little bit further. There's your linear recurrence relation. This time it's un plus 1 equals a un plus b. It's got three terms. u3 is 28, u4 is 30, u5 is 31. I want you to determine a and b and find u6 and u7. So find consecutive terms beyond what we have. So pause the video, have a crack at them, come back and see the solutions. So the first one, linear recurrence relation, is there. There's three terms, determine a and b. Well, the first thing we need to do is realise that if they're the first three terms, that means u1 is equal to 5, u2 is equal to 13, and u3 is equal to 29. Now, we have to set up relationships showing how these three terms match each other and are calculated using each other, and that then lets us have a pair of simultaneous equations we can solve. So un equals a times the previous term plus b. Well, u1 is there, we can't calculate the previous term for that, u0, so we don't have it. u2, now we know u2 is equal to a times u1 plus b. We also know that u3 is equal to a times u2 plus b. So we can use this in order to be able to substitute in these values and get a pair of simultaneous equations. So u2, so 13, equals u1 times a, so 5a plus a b. This one here tells me u3, which is 29, equals u2, 13 times a plus a b. So we've got a pair of simultaneous equations, we've got two variables, we can use these to calculate it. Now coefficients of b are matched, they're the same size, so we can subtract them. 13 take away 16, sorry, 13 take away 29 gives me negative 16. 5a take away 13 gives me negative 8a, and then b take away b is nothing. So negative 16 is equal to negative a. From that, I know that a is equal to 2. So I can take this and substitute it into any of these two equations here and get what the value of b is. Go to the top one, I get 13 equals 5 times a, so 5 2's, which is 10, plus the value of b. From that, I know that b is equal to 3. So I've got my values for a and b. I can then go back and set up the relationship un equals a, which I know is 2, times un minus 1, plus b, which is 3. So there you go, I've now got my recurrence relation. I've now got my linear recurrence relation. I can use that to calculate any consecutive term that I now need. Second one, so there you go, linear recurrence relation again. This time I've got u1 is 2, u2 is 4, u3 is 10. So I've told you the u1, 2 and 3. Again, find the values of a and b and find the relation. So again, we have to do the similar sort of thing. Set up recurrence relation, set up simultaneous equations and use them to calculate. So I know I can get u2 by doing a times u1 plus whatever b is, and I know I can get u3 by doing a times u2 plus whatever b is again. So I can use these and the values I've got here to set up my pair of simultaneous equations. So u2, 4, equals u1 times a, which is 2a, plus my b, and then u3, which is my 10, equals u2, which is 4, times the a, plus the b. Now again, the coefficients of the b's are the same, so I can just subtract the whole thing as a column sum. So I could do 4 take away 10, gives me negative 6, 2a take away 4a, gives me negative 2a, and the b's vanish. So negative 6 is equal to negative 2a, a has to be equal to 3. Again, now we take the value of a and substitute it into either of these two and we'll get the same answer. Last time I went for the top, this time I'll show you and I'll go for the bottom. Doesn't matter which one we do. So I've got 10 equals 4a, well a is 3, so 10 is equal to 12, plus whatever b is. Solving this, I get that b is equal to -2. Again, I get the same answer here. 4 would equal 6 plus b would equal -2. So there you go, I've got my a and my b. Now I need to find the relation, so substitute it. So I know that un equals a, which is 3, un minus 1, plus b, which in this case is -2, so it's take away 2. So there you go, we've got a recurrence relation. Un equals 3, un minus 1, take away 2. I can then use it to calculate any consecutive terms that I want for this relationship. Last one, linear recurrence relations. Un plus 1 equals a un plus b. Again, all I've done is change these, but it's still next term equals previous term. Doing something. It's still the same sort of thing. It has three terms, u3, u4 and u5. Determine a and b and find u6 and u7. Now, just because it's 3, 4 and 5 doesn't make any difference to our steps. The key thing is they're 3 consecutive terms. Because they're 3 consecutive terms, I can still work with it. So u3, I don't know u2, so I can't set up a relationship with that. u4, I know the previous, so I know then that u4 is going to equal a times u3 plus whatever b is. And I then know that u5 is going to equal a times u4 plus whatever b is again. So I can use them to set up my set of simultaneous equations. So, first one, u4 equals a u3 plus b. 30 equals a times u3, so it's 28a plus my b. And then for the second one, u5 equals a u4 plus b. What that lets me set up is 31 equals 30 times a plus whatever the value of b is. Again, I've now got a pair of simultaneous equations. The coefficients of b match, so I can simply subtract. So 30, take away 31, well, that's -1. 28a, take away 30a, gives me -2a. -1 is equal to -2a. A is equal to 1/2. Never have we said we can't have a fraction or a decimal amount for any part of it. So this is perfectly fine. A is equal to 1/2. What I can then do is substitute it in and calculate b. So if I go to the top, I know 30 equals 28 times a, so 28 times 1/2, that's 14, plus whatever the value of b is. From that, I know b is equal to 16. Using this, I can then set up my recurrence relation. I then know that un plus 1 equals a, so 1/2, times un plus the value of b, so plus 16. So now that I've got it, I can use it to calculate u6 and u7. I know that u6 is going to equal 1/2 times u5 plus 16. I know u5 is 31, so it's going to equal 31 over 2 plus 16. 16 over 2 is 32 over 2. Add the two of them together, and you get 63 over 2. We can then do u7. So I know that's going to be 1/2 times 63 over 2, so times the u6, plus whatever the value of 16 is. So that's 63 over 1/4, plus 16. 16 over 4, that would be the equivalent of 64 over 4. Add that onto the 63, and you get 127 over 4. So there you go, there's my values for u6 and u7. So I've been able to use it to calculate consecutive following terms. So it's fairly straightforward once we set it up. We just have to remember we need at least 3 consecutive terms, set up simultaneous equations, and use those to calculate the missing parts of your recurrence relation.